So mathematical description of equilibria. Okay, so suppose we have two systems, system A and system B. And for the simplest case, let's consider that both systems are made entirely of gas molecules. And suppose that for system A, the internal energy is UA, and for system B, the internal energy is UB, for the number of particles NA and NB, and the entropy is SA and SB. So let's write that down. So suppose we have two systems. A and B. And for the simplest case, let's consider both are made of just gas molecules. And internal energies of each are UA and UB. The number of particles are NA and NB, and entropies are SA and SB. We can also say that our total entropy is just the sum of SA and SB. Now, for the three equilibrias that we had, let's discuss how to develop these three formulas. So I'm going to do them stepwise. So let's do thermal equilibria. So from my second law of thermodynamics, what do I know? I know delta S equals Q over T. And from my first law of thermodynamics, I can rewrite this as du over T. Or I can also rewrite this as ds equals du over T, or ds over du equals 1 over T. So usually when you will see this written out, what you will see is it will be written out like this, V and N. What that means is that this condition holds for when V and N are held constant or fixed. I'm going to call this equation 1A. We're going to be using these equations quite a bit, so pay attention. Also, I want to talk about one other thing before we move on. You can do this without actually deriving anything, and by just using dimensions. So what do I know? I know the units of S are joules per Kelvin. Agreed? So may I write this as ds over du will become joules per Kelvin per joules. So the joules will cancel out, and what am I left with? 1 over Kelvin, which is nothing other than 1 over T. Okay. Number 2. Mechanical equilibrium. So if I start from the left-hand side of this expression, ds over dv at constant mu and n. May I rewrite this as ds over dv? Can I rewrite this as joules per Kelvin divided by meter cubed? What is joules? Joules is nothing other than Newton meters per Kelvin divided by meter cubed, or meters can get canceled with this too, and I get equals Newton per meter squared Kelvin. Or if I look at this, what is newtons per meter squared? It's nothing other than the units of pressure times Kelvin. So may I rewrite this expression as ds over dv equal pressure over T. And this is at constant N and constant chemical potential. So I'm going to box this equation. I'm going to call this equation 1b. Now comes something new that I want to focus in on. So number 3 was diffusive equilibrium. Now, what do I know? I know that my S total is the sum of SA plus SB. Now, if I ask a question and I say, what happens when I have ds over dn? I know that I can rewrite this as dsa over dn plus dsb over dn. Now, dsa plus dsb, dsa over dn plus dsb over dn must equal 0. I'm going to call this my butterfly equation. Now, I know that the system contains n total number of particles. Which means n must equal the particles contained in A plus the particles contained in B. Now, since this is diffusive equilibrium, I know that dn must equal 0. Or dna plus dnb must equal 0. This implies that I can write dna equals minus dnb. So from my butterfly equation, may I rewrite that as, so my butterfly equation will now become dsa over dna minus dsb over dnb equals 0. So can I rewrite this expression as dsa over dna equals dsb over dnb? Now, if I move this over a little bit, am I allowed to multiply both sides with negative t? This is now defined as chemical potential for system A, and this is defined as the chemical potential for system B. Or in other words, I can rewrite chemical potential as ds over dn at constant u and v as divided by minus t. put this equation in a box and call it 1C. Now, what we will discover later, then 1A, 1B, and 1C are mostly written as partial derivatives. Why? Because combining 1A, 1B, and 1C, I can write that my S is a function of U, V, and N. So my equations 1A, 1B, and 1C will in fact be written as 1A, 1B, and 1C can be written as partial S over partial U as 1 over T, partial S over partial V is written as P over T, and partial S over partial N is written as mu over T minus. And again, the quantities that are held constant remain the same. So in this one, it'll be V and N. It will be N and mu. And this will be U and V.